Okay, everyone. Today I'm going to make this video to explain this worksheet, and later on I will make another video to explain revision exercise 5. I hope you have already tried these two worksheets. Okay, so now let's take a look on question 1. This is the decomposition of steam. Okay, so now A is very easy. It's talking about a writing expression for the equilibrium constant Kp. Remember, this is Kp, not Kc. So you have to put the partial pressures together instead of the concentration, okay? So the Kp will be the partial pressure of this one as the numerator times the partial pressure of the hydrogen times oxygen, and it bears the square because the coefficient is 2 here, over the partial pressure of steam. Now remember, this is gas, so you have to include this in the mathematical equation. If this is a liquid, then you don't have to, okay? So this is the first part. Now, if you remember, how can we find out the partial pressure of a gas in a gas mixture? Okay, we need to find out the mole ratio because the partial pressure of a gas is equal to the mole ratio of this gas times the total pressure, in case if you forget this thing, okay? So B, 20% of the steam is dissociated in the hydrogen and oxygen at high temperature, total pressure of 1 atm. Now, total pressure this time is 1 atm. 1 atm, the question already told you. What is the pressure exerted by each of the 3 gases? Basically, the question is asking you the partial pressure of each of the gas, okay? So, in order to find out the partial pressure, as what I just said, you have to find out the mole ratio for each of them first, okay? So, same as before, we can form the ice table. Okay, now the question is saying that 20% of steam is dissociated, right? So originally you can let X, okay, you have X steam and then 0, 0. Since 20% is going to the right-hand side, so the change will be negative 0.2x. And this will be positive 0.2x since the mole ratio is 2 to 2, 1 to 1. And this will be 0.1x because the mole ratio is 2 to 2 to 1. Any question? Then let us look at the water, the steam. X minus 0.2x will be 0.8x, and this will be 0.2x, 0.1x. So we can work out the total number of mole first, okay? Total number of mole will be the sum of these 3. Okay, the sum of these 3. So it will be 0.8x plus 0.2x plus 0.1x. It will be 1.1x, okay? So now then you have to work out the mole ratio of each of them. And then from this equation, you times the mole ratio of each of the gases with the total pressure, then you can find the partial pressure, okay? So let us work out the mole ratio of steam first. It will be the total as the denominator and then the equilibrium mole as the numerator. As you can see, the x can be cancelled. So it will be this one. And then you can work out the value. You can take more places. Okay, normally during the steps you take 4 sig figs, and then the final answer you take 3, then your answer will be identical to the suggested answers, okay? Then the mole ratio of hydrogen will be 0.2x over 1x, okay? Then same as before, the x can be cancelled, so it will be 0.2 over 1.1. So it will be 0.1818 2, okay? The last one will be oxygen, 0.1x over 1.1x, okay? Then it will be 0.0 909. Okay. Oh, then you can work out the partial pressure. As what I mentioned, the partial pressure is basically the mole fraction times the P total. Right now, the P total, when you look at the question, is 1 atm. Can you see that? It's 1 atm here, 1 atm. So it's very easy. So basically, the mole fraction will be the partial pressure because the total pressure is 1 atm. You just times each mole fraction number by 1. Then you can, but for better presentation, you can write it out. Because sometimes the total pressure will not be 1. Okay, so you have to present the step. So to let the marker know that you know the method, that is you times the total pressure with each of the mole fractions, okay? Okay, the last step is very easy. Once you get this free number, you are going to substitute this free number into this equation, the one in A, okay? Then you will know the answer, okay? Then we can do it together. So Kp will be equal to, let's see, okay. I rewrite the equation. Okay? Yes. I missed 2 here, sorry. 2, okay? Because there is 2. So 2, 1, 2, okay. Then we start substituting the number. Hydrogen is 0.18182 times oxygen 0.0909 over water 0.7273. Okay. So it would be 5.683 times 10 to the power negative 3. So when you look at the unit, since these two can cancel in terms of the unit, so the unit will be ATM. Any question? Now we break down the video into 3 parts because I don't want to make it so long. So the next video will be explaining question 2 and see if I have enough time to explain question 3 at the same video. Okay, see you.